So in this video I'm going to go through the key spec points of P2, just like in my last videos where I've been through its key spec points of B2, of C2. So P2 is all about physics from the AQA, this is specific to the AQA GCSE syllabus. So the first topic I want to start on is forces. So you've got to talk about Newton's laws when it comes to forces, and the first law that's always discussed generally, although it's not the Newton's first law, it's actually Newton's third law. That's one that's the most difficultly understood, or the one that's not understood the best, but that's asked about the most. So whenever you've got two objects interacting, so the key thing there is the fact there's two objects interacting, the force they exert on each other are equal and opposite. So what that means is if you've got object A and you've got object B, object A applies a force on B, then B applies the same force back on A. So in other words, if I was to push on a wall, the wall would push back on me with the same size force. Okay, so both forces are not acting on the same object, they're acting on different objects. So if a propeller blows air this direction, the air blows back on the propeller fan. Or if a rowing paddle blows on the pushes against the water this way, then the water pushes against the paddle this way. A number of forces acting on a point may be replaced by a single force that has the same effect on the motion as the original forces all acting together. This is known as a single resultant force. Okay, so resultant force is when you've got a few forces acting. So you've got a force of that way, another force that way. So that's 2 newtons, and say that's 7 newtons. Overall, because they're acting in opposite directions, that's 5 newtons this way. Okay. So then we've got another situation. Let's say we've got 2 newtons that way, and we've got another one of 2 newtons that way. Those two forces together would add up to overall be 4 newtons in that direction. Okay, so resultant force acting on an object may cause a change in the state of rest or motion. Okay, so in other words, if there's a resultant force that leads to change, so that would mean it's either going to accelerate, okay, or it's going to change direction. Changing direction is an acceleration, okay. So it's going to either change direction or change velocity. That's what's going to happen there. It says about over here that it should be able to determine the resultant force of opposite or parallel forces acting in a straight line, and that's what we've just done over here. Excellent. Let's keep going. So, resultant force acting on a stationary object is 0, it will remain stationary. So if the resultant force is 0, it will remain stationary, if it's originally a stationary object. If it's not 0, the object will accelerate, and the key thing is it's in the direction of the resultant force. So overall, we had a resultant force to the right on the previous slide all the time. That means the object will always accelerate in that direction. If the resultant force is acting on a moving object, then if it's 0 resultant force, it will continue to move at the same speed, same direction. Okay, if it's not 0, again that causes it to accelerate, and that accelerate happens in the same direction as the resultant force. Okay, so if an object is going this way and the resultant force acts this way, the acceleration happens backwards. That means it's decelerating. So moving on from forces to motion, Newton's second law comes into this, which is essentially F equals ma. That can be rearranged for A equals F over m. Okay, so that's acceleration, force, and mass. So after that, we generally get into the idea of distance time and velocity time graphs. Okay, so we need to understand this in a bit of detail. We need to understand the key word here that says gradient. And if you need to look that up, then please do look it up. It is a skill that you need to be able to do. So if you've got a distance time graph, so you've got distance on this side, and you've got time on this side. You've got a graph like this. It says the gradient of distance time graph represents speed. So to do the gradient, you're looking for the change in y, how much it changes this way, okay, how much it changes on the y-axis, divided by the change in x, how much it changes this way. So you do the change in y divided by the change in x, and that tells you the gradient. So the gradient of a distance time graph tells you speed. Okay, so higher tier students will need to calculate the speed of an object from the gradient of a distance time graph. You will actually need to do that, to do the actual calculation. Take the gradient, and that will therefore tell you the speed. Okay, so you're not just taking a distance and a time, you're taking the gradient of it, remember. The velocity of an object is a speed in a given direction. So velocity is a speed and a direction. The acceleration of an object is given by the equation of acceleration equals final velocity, so how fast it's going at the end, take away initial velocity, how fast it's going to begin with, and all of that divided by the time. Right, so if we've got a velocity time graph now, so previously there's a distance time graph, a very poorly drawn velocity time graph, okay? The gradient of that graph this time represents the acceleration. So if I did the gradient of this, again changing y over changing x, that would tell me the acceleration. Okay, again calculating that would is what higher tier students need to do, so they actually need to do that calculation. The final part over here says calculation of a distance travelled by an object from a velocity time graph. So say I've got a velocity time graph over here now. Let's do a different shape to that graph. So it goes like this. If I want a distance travelled, I need the area under here. Okay? Let me show you what I mean by that. So if I figured out the whole of this area under the graph by breaking it into triangles and squares, that would tell me the distance travelled. That whole highlighted area would tell me the whole distance travelled there. So break that into a triangle, figure out the area of that triangle. Break that into a rectangle, figure out the area of that rectangle. Break that into another triangle there, figure that out. Another rectangle there, figure that out. Okay, so you can calculate the distance travelled from velocity time graph as well. Okay. Now remember, the different shapes of velocity and distance time graphs tell you different things. Okay. So if you've got a steeper gradient on a velocity time graph, it means it's accelerating faster. If you've got a horizontal line, that means it's going at the same speed. On a distance time graph, if you've got a steeper gradient, that means it's going faster. If you've got a horizontal line, that means it's stationary. Right. I just want to go through one more quick one and then we'll end this video, and that's on forces and braking. Okay, so when you're braking a car, it undergoes certain forces. Okay, when a vehicle is travelling at a steady speed, the resistive forces balance the braking force. So in other words, the forces pushing the car forward are balanced by the forces pulling it back, the braking force. The resistive forces, sorry. Driving force pushes the car forward, the resistive force pushes the car back. The greater the speed, the greater the braking force needed to stop it. So the faster you go, the more braking force you're going to need. The stopping distance is the sum of the distance the vehicle travels, while the thinking distance, and the distance travelled while braking, the braking distance. So in other words, saying the stopping distance is equal to the thinking distance added to the braking distance. So driver's reaction time affects the thinking distance essentially. It can be affected by drugs and alcohol. Okay, so the brakes of vehicle, so when you apply the brakes, work is done. So work, remember, is energy. By the friction between the force of the brakes and the wheels, and that reduces the amount of kinetic energy. So if you're hitting the brakes, you're reducing the amount of kinetic energy. That kinetic energy is becoming heat, remember. That's being transferred to the surroundings. So you say heat transferred to the surroundings. That causes the temperature of the brakes to increase because of that braking that actually takes place there. The braking distance can be affected by the road, by the weather, and poor conditions of the car. Okay, they're the main factors that affect that. Okie dokie. Right, thank you very much for watching this video.